Hello everyone, and welcome back to Mr. Anderson's Algebra 1 lessons. Today we are going to take a look at a system of equations review entailing graphing, substitution, and elimination. We're going to start off with graphing a system of equation, and this is assuming that they give you a graph and they give you two equations they want you to find the solution for. Now remember, when you're working with a system of equations, the solution you're looking for is where the two equations meet or cross on either a graph or an equation, and you're looking for the coordinate point where they meet, thus the solution, the x and the y that makes each statement true. So this example, we're going to take a look at graphing, and they give us two equations here. And it's as simple as graphing a linear equation if you know how to do that. So assuming that you know how to graph a linear equation, these are all in the form of y equals mx plus b, or slope-intercept form, because you have the slope and you have the y-intercept, and you'll be able to plot these and find the slope and find where they cross. So let's get into it. Negative 2 is your y-intercept here for the first equation, and so you are going to plot that along the y-axis down here at negative 2. And the slope for this equation is negative 5. Now if you like to think of rise over run, that would be going down 5 over 1. So we just simply count down 1, 2, 3, 4, 5. And go over 1, and there is your next coordinate point. These two coordinate points are on the same line, and if you want another coordinate point, you simply just count up 5 and backwards 1. So 1, 2, 3, 4, 5, backwards 1, and there you go. So I got 3 points for my graph, and I'm going to cross the line. There's my first equation graphed. The second equation is y equals x plus 4. So the y-intercept here is 4. So I put my coordinate point at 4. 1, 2, 3, 4. And my slope is 1. So I'm going to put a 1 in front of that. That means I go up 1 over 1. Down 1 over 1. So it looks like they cross right here on the graph. And so what I'm looking for when I'm graphing this system is I'm looking for this point. That's where they cross. So the solution is this coordinate point, and that's where they cross. So that looks like it's negative 1 on the x and positive 3 on the y. And so this is your ordered pair where those two graphs cross. So that's example 1, using the graphing of graphing a system with two equations given to you. Draw the graph, find where they cross. Example number 2 here today is we're going to take a look at two equations, and they ask us to solve using the substitution method. That's basically where you solve for one variable and plug it back into the other equation and solve for the other missing variable. So looks like we got 4x plus 7y is equal to 6, and x minus 5y is equal to 15. There's an equation here that I see that is a lot easier to solve first, and that is this equation. I'm choosing this equation because x is alone, and I can simply move the 5y over to the other side so that I can isolate the x. Once I isolate the x, I can then substitute what it is equal to back into this equation up top, leaving me with just the y variable to solve. So I'm going to do that first. I'm going to add 5y to each side and solve for x. X is now equal to 5y plus 15. Since I know that x is equal to 5y plus 15, I now can substitute it back into this equation. So substitute. Plug that back in. And I'm going to use that to help me solve for this guy. I'm going to use it to help me solve for y. Because what you should notice now is that I just have a y variable. And now I can combine like terms and solve for y. And once I get the missing y, I can plug it back into here because that's what x is equal to. So, solve for y here. Simply got to distribute first. So 4 times 5y is 20y. 4 times 15 is 60, so plus 60. And then that 7y is just hanging out, so we just bring it up here with us. Equals 6. And now I just combine like terms, and I begin to solve for the y. So, simply combining like terms, 20y plus 7y is 27y plus 60 is equal to 6. I subtract 6 to each side, or 60 to each side, and you have 27y is equal to negative 54 60, so negative 54 here. And now to get y by itself, I simply just divide by 27 to each side like so, and y is going to equal negative 54 divided by 27 is negative 2. So I now take this y equals negative 2 and I plug it back into this y over here because this is what x is equal to. So we don't know exactly yet because we were missing the y component. Now that we have the y component, we can plug it back in. So x equals 5 times negative 2 plus 15. Do some simple math. Negative 10 plus 15. X is equal to positive 5. So if you were looking to say what the ordered pair is where these two equations cross on a graph, you would say 5, negative 2. And that would be your solution there. And that's how you would solve using substitution method. Now, on to the next example. So this example we're solving using the elimination method. Now the elimination method, if you remember, and this is review, you are trying to add the two equations together to cancel out a missing variable and solve for the other. Now this example looks like if we tried to add the two equations together, nothing would cancel out. So if I tried to add these two, you would get 3x plus 5x, which is 8x. Negative 3y minus 9y is negative 12y, and so on and so forth. Nothing cancels out. In order to find something to cancel out, we have to find a variable that we think would be easy to cancel out. Thus, if you multiplied the equation by something, you could essentially cancel it out. Now I look at 3y and 9y, and I notice that if you multiply the 3 by 3, you will get 9. And if you added those together, you could cancel them out. So what I'm going to do is I'm going to multiply the top equation by negative 3. And what that's going to do for me is it's going to be able to cancel that stuff out. So I'm going to distribute the negative 3 to everything, and I stress everything in this parenthesis set so that you make sure you get all the right terms for able to subtract here. So negative 3 times the 3x is negative 9x. Negative 3 times negative 3y is positive 9y. And negative 3 times 9 is negative 27. That's the new term. The old term on the bottom stays there, so you can bring that over. And look at what we find here. If we were to add these together, you notice that the 9's would cancel out and create a 0. So I would do that. That creates a 0. And we're just adding straight down. Negative 9x plus 5x is negative 4x, and this is a plus 0, and then negative 27 plus 7 is negative 20. So what you end up with is negative 4x is equal to negative 20, and then you simply just divide by negative 4 to each side, and this is going to give you what x is equal to. X is going to be equal to positive 5. So we found that first. Great. And now you can take that positive 5, and I would plug it back into an original equation. Probably this one up here, since nothing happened to it. And you can use that to find what y is equal to. So I'm going to do that over here. I'm going to take 5x minus 9y is equal to 7. I'm going to plug in the 5, and I'm going to use it to find the y. So we have 5 times 5 minus 9y is equal to 7. You find that's 25 minus 9y is equal to 7. Then you subtract the 25 to each side. You have 9y. You have 9y, negative 9y is equal to negative 2. It's negative 18. So now that you simply just subtract or divide by negative 9 to each side, y is equal to positive 2. And that is how you would solve two equations using the elimination method. Now, for the final example, I'm assuming that you are following along with my guided notes from my Google Classroom. And so I will be reading the word problem to you. If you're just watching this video for fun, I will be writing the equation from the word problem that I'm reading. So, we will be doing a word problem example, and the word problem example is going to be using the elimination method. Okay? So, the word problem says, Stefan and Deshawn are selling cookie dough for a school fundraiser. Customers can buy packages of sugar cookies. So sugar cookies is one thing they can buy. And they can buy oatmeal cookies. I'm never a big fan of oatmeal cookies. But nonetheless, they can buy those. So Stefan sold 12 packages of sugar cookies and 3 packages of oatmeal cookies. So I see that Stefan sold 12 packages of sugar cookies. So I'm going to do SC for sugar cookies and OC for oatmeal cookies. And Stefan sold 12 sugar cookies plus 3 oatmeal cookies, and he made $162. So there's the first equation, it looks like. Deshawn sold 6 packages of sugar cookies. So Deshawn sold 6 packages of sugar cookies. So 6 SC plus and he sold one package of oatmeal cookies. Man. And Deshaun made $74. $74. Find the cost of each of the packages of sugar cookies and oatmeal cookies. So I got my two equations here, and this is just like the problem we saw above. We can add these two together and cross out a variable. So if I'm going to do this, I think I'm going to take what I learned from last one, and it looks like I'm going to have to multiply one of these equations by a number so that I can cancel that out. And it looks like the easiest one to cancel out is the oatmeal cookies. So I got 3 oatmeal cookies on top and 1 oatmeal cookie on bottom. If I multiply the bottom equation by -3, everything will the 3's will cancel, and then I can solve for the sugar cookies. So that's what I'm going to do. I'm going to distribute that -3 to everything, and I'm going to make an entire new equation for the bottom. 62. Alright, so -3 times 6 is -18, and that's sugar cookies. And then -3 times 1 is -3 for oatmeal cookies. And then we got -3 times 74. -3 times 74 is -222. So now I simply just add these two equations here, and I will watch the variables cancel. These will cancel, and I'm left with SC, or sugar cookies, left over, so I can solve that first. So we just take 12 minus 18, and you get -6. So you got -6 sugar cookies is equal to 162, take away 222, and you get -60. So if you divide by -6 to each side, you find that the sugar cookie package is equal to, I think, $10. $10. That must be some pretty good sugar cookies. So now that I've found what the sugar cookies is equal to, I can take that and plug it back in to find out what the oatmeal cookies are equal to. And I'm going to use the original equation up top here. 12SC plus 3OC is equal to 162. So we just plug in our $10 for the SC here, plus 3OC is equal to 162, and then I just find all of that out. So 12 times 10 is 120, plus 3OC is equal to 162. Subtract that 120 from the other side, and you find that you have 3 oatmeal cookies is equal to 42, and when you divide by 3 here, you find the real reason why the oatmeal cookies never get sold, and that's because oatmeal cookies are $14 a package. Jeez. I never knew why people liked oatmeal cookies anyways, but $14 seems like a lot for cookies. Anyways, regardless, that would be how you would solve that word problem, and that is the answer that you'd be looking for. Again, thank you so much for following along. This has been Algebra Lessons with Matt, and I hope you have a wonderful day. Peace out.